In electrical installations, especially when feeding multiple panels from a single feeder, understanding and adhering to tap rules is critical for safety and code compliance. A tap rule addresses situations where conductors are tapped from a larger feeder to supply smaller loads, such as individual panels. Let's consider a scenario where you have four 100 amps panels engineered to be fed from one feeder, with panels stacked on multiple floors of a building. The original plan involves running conduit and pulling continuous wire from the main distribution point, or NDP, to the first floor panel and then up to the fourth floor. Now, if you were to run metal-clad, or MC, cable from the NDP to the first floor panel, tap at that location, and continue with MC cable to the upper floors, a question arises: would this be a violation of the tap rule because the wire is not continuous? The answer is no. Running MC cable in this manner is not necessarily a violation of the tap rule, provided that certain conditions are met. Firstly, the feeder conductors must be continuous from the MDP to the first floor panel without any taps or splices in between. This means the primary feeder cable should run uninterrupted to the first panel. Secondly, the tap must be made at an approved location within the first floor panel. The panel must be appropriately rated, and the connection method must be in accordance with the electrical code. Thirdly, the tap conductors must be sized appropriately and meet all the requirements of the National Electrical Code, or NEC. This includes ampacity, insulation type, and proper termination. Now, addressing the measurement of the 25 FT tap rule, the 25 FT measurement starts from the point of the tap. Therefore, in the scenario, the measurement would begin at the tap location on the first floor panel. This is in accordance with the NEC Article 310.15b3, which provides specific guidelines for tap conductors. This section states that tap shall not be permitted in parallel with any overcurrent device in the feeder circuit. Also, taps from a feeder to a branch circuit shall not be made at any point more than 25 FT distant from the branch circuit overcurrent device. Let's delve deeper into these requirements. The primary purpose of the tap rule is to protect the smaller tap conductors from overcurrent situations. Without proper protection, these conductors could overheat and cause a fire. The 25 FT tap rule is just one type of tap rule. There are also 10 FT tap rules and engineering tap rules, but this discussion will focus on the 25 FT tap rule for simplicity. The code specifies conditions under which tap conductors can be used, including limitations on their length and ampacity. For instance, the tap conductor's ampacity must not be less than 1/3 of the overcurrent protection device protecting the feeder conductors. This ensures that the tap conductors can safely carry the intended load. Additionally, the tap conductors must terminate in a single circuit breaker or set of fuses that will limit the load to the ampacity of the tap conductors. It is imperative to understand that the 25 FT rule is not a free pass to run undersized conductors. All applicable codes and standards must be adhered to. Moreover, the tap conductors must be protected from physical damage. This can be achieved by running the conductors through conduit or using armored cable like NC cable. When installing MC cable, ensure that it is properly supported and secured, and that appropriate connectors are used at all termination points. Using the correct connectors is crucial for maintaining the integrity of the grounding path. Proper grounding is essential for safety and for preventing electrical shock hazards. In the context of the condo building scenario, it is important to consider the overall electrical system design. The feeder supplying the panels must be adequately sized to handle the total load of all four panels. Load calculations should be performed to determine the minimum feeder size required. The feeder overcurrent protection device must also be sized appropriately to protect the feeder conductors. Furthermore, coordination studies should be conducted to ensure that the overcurrent protection devices in the system are properly coordinated. Coordination helps to prevent nuisance tripping and ensures that only the affected portion of the system is de-energized in the event of a fault. Another important consideration is voltage drop. Voltage drop occurs when the voltage at the load end of a conductor is less than the voltage at the source end. Excessive voltage drop can cause equipment to malfunction and can also reduce the efficiency of the electrical system. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. In general, the voltage drop should not exceed 3% in branch circuits or 5% in feeders. To minimize voltage drop, use conductors that are large enough for the intended load and keep conductor runs as short as possible. Also, consider using conductors with lower resistance, such as copper. In summary, when tapping into a feeder to supply multiple panels, it is essential to adhere to the tap rules outlined in the NEC. These rules are designed to protect the tap conductors from overcurrent and to ensure the safety and reliability of the electrical system. Remember that the 25 FT measurement starts from the point of the tap, and that the tap conductors must be sized appropriately and protected from physical damage. Always consult with a qualified electrician or electrical engineer to ensure that your electrical installations comply with all applicable codes and standards. Neglecting these details can lead to hazardous conditions and costly repairs. Furthermore, in a multi-unit dwelling like a condo building, there may be additional requirements or restrictions imposed by the local authorities or the building management. Always check with the relevant authorities before commencing any electrical work. It's also important to maintain accurate records of all electrical work performed, including wiring diagrams and load calculations. These records can be helpful for future maintenance and troubleshooting. Consider the potential for future expansion when designing the electrical system. It may be wise to install a larger feeder than is currently required to accommodate future loads. This can save time and money in the long run. Always use high-quality electrical components and materials. Cheap or substandard components can fail prematurely, leading to safety hazards and costly repairs. Regularly inspect the electrical system for any signs of damage or deterioration. Look for loose connections, frayed wires, and corroded components. Address any issues promptly to prevent them from escalating into more serious problems. Remember that electricity is dangerous and should only be handled by qualified professionals. If you are not comfortable working with electricity, always hire a licensed electrician. It's also a good idea to educate yourself about basic electrical safety principles. This can help you to identify potential hazards and take steps to prevent accidents. In the context of our discussion, specifically regarding the use of MC cable, it's worth noting that MC cable offers certain advantages over traditional conduit and wire installations. MC cable is easier to install, especially in tight spaces, and it eliminates the need to pull individual wires through conduit. However, MC cable is not suitable for all applications. It is generally not recommended for use in wet or corrosive environments. Additionally, MC cable may not be allowed in certain types of buildings or occupancies. Always check with the local authorities to determine whether MC cable is permitted for your specific application. When using MC cable, it is important to follow the manufacturer's instructions carefully. This includes using the correct connectors and supports. Also, be sure to properly terminate the cable shield to ensure a proper grounding path. The NEC provides detailed requirements for the installation of MC cable, including requirements for bending radius, support spacing, and termination methods. These requirements must be followed to ensure safe and reliable installation. Now, let's consider some additional factors that may influence the design of the electrical system in a condo building. The available space for electrical equipment is often limited in condo buildings. This can make it challenging to install the required feeders, panels, and overcurrent protection devices. Careful planning and coordination are essential to ensure that the electrical system can be installed safely and efficiently. Another consideration is the aesthetics of the building. The electrical system should be designed in a way that minimizes its visual impact. This can be achieved by concealing the wiring and equipment as much as possible. In some cases, it may be necessary to use special types of electrical equipment that are designed to be aesthetically pleasing. The electrical system should also be designed to be energy efficient. This can be achieved by using energy-efficient lighting and appliances, and by implementing strategies to reduce energy consumption. Energy efficiency not only saves money on utility bills, but it also reduces the building's environmental impact. The electrical system should also be designed to be accessible for maintenance and repairs. This means providing adequate access to the panels, feeders, and overcurrent protection devices. It is also important to label all of the components clearly so that they can be easily identified. Now, returning to the specific scenario of tapping into a feeder to supply multiple panels, let's consider some alternative approaches. One alternative approach is to use a distribution block. A distribution block is a device that allows you to tap into a feeder without cutting the feeder conductors. This can be a convenient option when it is not possible or practical to make a traditional tap. Another alternative approach is to use a panel with multiple main breakers. This allows you to supply multiple loads from a single panel without the need for separate feeders. Each main breaker protects a separate circuit, and the panel is designed to distribute the power evenly among the circuits. In conclusion, understanding and adhering to tap rules is crucial for ensuring the safety and reliability of electrical systems, especially when feeding multiple panels from a single feeder. The 25 FD tap rule, as outlined in NEC Article 310.15b3, provides specific guidelines for tap conductors, including limitations on their length and ampacity. When installing MC cable, it is important to follow the manufacturer's instructions carefully and to comply with all applicable codes and standards. Always consult with a qualified electrician or electrical engineer to ensure that your electrical installations are safe and code compliant. Remember that electricity is dangerous and should only be handled by qualified professionals. By following these guidelines, you can help to ensure the safety and reliability of the electrical system in your building.